Hello, fabulous third graders! Today we are going to talk about arrays and multiplication. Let's say Kevin puts stamps he collects in an album. How many stamps are on this page of his album? Well, these stamps are displayed in an array. An array shows objects arranged in rows and columns. Each row has an equal number of stamps, and each column has an equal number of stamps. There are 6 rows on this page and 3 columns. Now, when I use an array to multiply, I want to multiply rows times columns. So I'm going to multiply 6, which is the number of rows, times 3, which is my number of columns, and I will get 18, which is the total number of stamps. Now, remember I said we want to multiply rows first times columns second. So there's a way that I remember rows, columns, and that's by thinking of a soda I remember called RC Cola. Now, RC, rows, columns. It helps me remember the order to multiply when we're using arrays. Now, what if I flip the stamp page on its side? Well, I'm going to think to myself, RC Cola, RC, rows times columns to get my total number of stamps. So now that I flip the page on its side, I have 3 rows and 6 columns. And I will still get 18 from my total number of stamps. That's because of the commutative property of multiplication. Now remember, the commutative property of addition told us that changing the order of addends did not change the sum. In the same way, the commutative property of multiplication tells us that changing the order of the factors does not change the product. So let's take a look at one of the multiplication sentences we've been working with. 6 times 3 equals 18. 6 is our first factor, 3 is our second factor, and our product, the answer to the multiplication problem, is 18. So because of the commutative property of multiplication, if we change the order of those factors, we will get the same product. 3 times 6 equals 18.